All right, I'd like to go through a little bit on some category 4 venting and combustion air for those types of appliances. So this particular PowerPoint goes through the questions, or has a set of questions that's associated with them. That's number 25 for category 4 vent systems. So let's take a look at them. So describing a little bit about category 4 systems. So the first thing that I want to point out is that the way you're going to identify a category 4 vent system is usually on the unit tag or the label on the unit, which will identify that. Now, most experienced technicians in the field, they can spot a category 4 appliance fairly fast just by the types of venting materials that are used. But for a novice, they may not necessarily spot that right away. Sometimes they're not as obvious. So let's take a look at it. So a positive vent pressure system. So you got to think back on the categories. Category 4 is positive pressure, and it's got some rules that keep the vent temperatures less than 140 degrees higher than the dew point. So something less than that. So you got to have a corrosion resistant material. It's got to be leak free. It's got a flue gas temp less than 140 above the dew point. So it's got to be less than that. It cannot be common vented. Now, I should put a little asterisk next to that. There are a few scenarios or a few systems where they actually can be common vented, but it's unusual, and it's definitely by manufacturer, and they would have to approve it. It's really an odd thing that you would normally. So normally, I would say generally you would not see these common vented together. So you wouldn't see two furnaces in the same vent system together. They got to be sized according to the manufacturer. They're the ones who dictate those rules, and there is no guarantee that that appliance will actually be condensing. So, and I specifically identify that as category 4 boilers, especially if they're running return water temperatures that are going to be slightly greater than, let's say, 130 to 135 degree temps. Chances are, especially 135, chances are they're not going to condense. So depending on how they set up the combustion, that will dictate that. So it's one of those where just because it's category 4 does not guarantee it's going to be condensing. It should be, but it generally doesn't. So, all right. So let's take a look at what is the highest expected flue gas temp that would be identified in a category 4 system. Well, generally, if you assume the dew point would be approximately 130 degrees, the highest flue gas temperature that you'd expect to see out of any types of furnace or boiler that would be considered category 4 would be, if you add the 140, puts you at about 270 degrees. So we would expect fully that our vent temperatures, those gases would never be higher than 270 degrees is the assumption. And that's pretty high, I mean, for a category 4 system, but there are category 4 systems out there that are in the 87 to 89% efficient range, and they are barely condensing. So they run some of these temps that are up in the 2-something range. Okay, so what temperature, should be limited to using, you wanted to use PVC material. So kind of gave it away a little bit here, but if you take a look at the rules or the regulations and the ratings of a PVC, of solid core PVC pipe, 140 degrees is the normal max temp of that type of pipe. No coincidence to what the code rating is or anything. It's just 140 degrees. When you start getting above that, the PVC pipe will actually start to soften, and you can get sags in that pipe so much easier. The other issue is that when you start getting temperatures in excess of the 140, some of the condensate that runs back into that appliance or back through that piping system will start to leach into the higher temps, will leach out the, let's say, the chemicals out of the PVC, and when they get back into a furnace or a boiler, what they'll do is they'll actually start to eat away at those materials, and it can do that to even to the lower grades of stainless steel, it'll even eat away at some of those. So that creates a little bit of a problem for us for most heating units. So you got to be really careful with that. In some situations, certain appliances would put a condensate fitting leaving the boiler or leaving a system where if they would, all the condensate would roll back into a T and then drain out before it got into the boiler. Now, there's no guarantee that it's going to work. There's better alternatives out there. PVC would not be the one to use. For a normal residential condensing furnace, in most cases, it's completely acceptable and it works fine. But there are applications where it's probably not the best fit. All right, so next question I want to ask is, why is it necessary to power vent a high efficiency furnace? So I've got a picture of a high efficiency furnace here that's vented in PVC. And why does it have to have a power vent? So, well, the first thing is their flue gases. Their flue gas temps are generally so low. So in a lot of these cases, especially for a condensing furnace, you might be dealing with flue gas temps that are going to be closer to 110 degrees, 110, 120 degrees. So it would not shock me to not have enough energy for that. I've seen them be down as low as 70, 80 degrees if you're running cold enough return temps for return air. So you're not going to get the energy needed to vent these. All right, the next thing I want to do is I want you to list the key items or talk about the key items of a high efficiency furnace that would operate in a negative pressure. So there's a couple of things that I want to point out. So the first thing is the combustion air inlet is in a negative vent pressure, a negative pressure. That's the intake box here. So that's one thing. The next thing would be, and we also call that kind of so you got intake air and you also have the burner box. That's going to be it. Then you have, of course, the primary exchanger or the combustion chamber, the primary exchanger, and then of course what they call the condensing heat exchanger, or I'll call it the secondary heat exchanger. Everything is under a negative pressure in this case, including the condensate area that's listed down below here at that outlet. Now that's fairly typical of most furnaces. Now, is there any of them that operate in a positive pressure? Well, yeah. The one that does is actually going to be the exhaust pipe. So the exhaust vent pipe leaving the blower or the inducer fan typically is associated with a positive pipe. Now, there are exceptions to this. So this is more typical. There are applications out there that will indeed have a forced draft system where it will be more like a power burner, and that will change the thing. But typically most furnaces, they intentionally try to put the heat exchanger under negative pressure to avoid and minimize the risk of having carbon monoxide, dangerous carbon monoxide, be vented out into the space along with the combustion air that's moving around or the room air that's being circulated over that exchanger. So what is the advantage of that design? So what I'm going to talk about specifically is what they call a counterflow design. Now, the intent of the counterflow design is such that we can achieve very high efficiency on heat transfer. So if we take an appliance and we can somehow cause the coldest return air to hit the coldest temperatures of the flue gases in a high efficiency heat exchanger, we can cause those gases to drop lower and lower and lower, and even provide us better condensate extraction, we'll call it, from the flue gases. Since we have a certain amount of sensible and a certain amount of latent energy, that makes sense for us to do that. So that's really one of the benefits of that. Almost every appliance will try to utilize this if they want to have the most heat exchange on this system. But that's called counterflow. My boy Will Farrell, he's having a good old time. He's excited about this. So let's take a look at the next thing. So what about the sizing, and why is the volume of the flue gas so reduced? If you notice, most furnace pipes on a high efficiency furnace are anywhere from 1.5 all the way up to 3 inches. In some cases, they're up to 4 inches on the really big units. but why are they so small? Why is the volume of the gases so reduced? And why are the vent pipes, really so small? So when we take a look at the significant cooling effect of the flue gases, a lot of that large volume of water and water vapor, when you start to cool those temps down, they will reduce the volume substantially. So and that's typically one of the reasons why that happens. So you cool them down enough, you can really get those molecules to really become much, much smaller. And that allows us to really use those smaller pipes. So I want to talk a little bit next about some of the items that maybe we should consider when we're venting a Category 4 furnace. So I've got an application with a furnace in a basement. I'm showing combustion air and intake pipes running through maybe some, interior walls up and through an attic and out the roof. And a lot of systems, a lot of people, contractors will try to put a furnace in similar to this, such that it kind of reduces the penetration on the exterior side of the house, but it does put it through the roof. Now, they may be using a concentric vent or something more, maybe a little cleaner to the eye, and it works fine in some applications. It doesn't work fine in all applications. So let's take a look at some of these. So the first rule that I would say is a good recommendation is to insulate the exhaust in these unconditioned areas, so the unconditioned areas. So this is really, and especially in an attic. So if you are going to run a vent pipe in an attic, you have to insulate that pipe, or you're going to have problems where those gases could potentially freeze if you're in a colder climate. It probably would take temperatures that would be 10 degrees or less in most cases, but it certainly could happen in warmer than that even, but certainly below freezing. Insulate the intake in the conditioned areas, especially if it's concealed. So insulate those to prevent any type of condensation that might occur in those areas. So those are all beneficial to some extent. Think about it, if you're bringing air that's 10 below zero outside and you're running it through an interior space, if there's not a vapor barrier around that pipe or insulation around that pipe, vapor barrier or not, it's going to condense. So you want to be careful with that. The intake and exhaust pipes, they should terminate also in the same pressure plane. And then, of course, condensing furnaces shouldn't be installed in unconditioned space if you can help it. There's issues with that, and obviously the most obvious would be if you put it in a place where it would freeze, you run the risk of the traps drying, not drying, but freezing actually. So let's take a look at this one. So I've got a few images here of an install and a couple of things just to point out. So the first one is, supporting your vent pipes. So on my drawings here, at a minimum, every 5 feet, they should be supported. Now, there again, you want to do that to make sure that those pipes are not going to sag. Maybe it could be heat, it could be time. People could hang things on them that could create problems. So that's a good rule. You can certainly do more, but 5 feet is generally the most you'd want to go on most PVC pipes. Slope them back a 1/4 inch a foot as a general rule of pitching. So you'll notice that slope on this picture here is showing it's up, slope back towards that furnace. Generally, that's the way most applications are, is where the furnace will be pitched upward, and if you can go more power to you. If you cheat a little bit on that and you don't pitch it enough, you can really run into some problems with a lot of that moisture not actually draining back to that furnace and hanging in the pipe, and it will stay in there until the furnace fan stops, until the venter fan stops, and then you could get an excessive rush of moisture, creating a problem for that inducer assembly. And of course, terminate, the exhaust pipe should terminate 12 inches above the intake. So what I'm kind of referring to is the separation between this pipe and this pipe. You'd like to see 12 inches of separation between those And in some cases, you actually are going to need more than that. And I would say that would be almost minimum. You're better off in most cases to have a little more separation, and this is especially true if you're dealing with multi-stage or variable stage equipment, where when you go into the lower flows, you're going to not have enough velocity to push under low firing rates. You're not going to have enough velocity to push those gases out of the building and away from that intake pipe, and you'll end up getting recirculation on there. So that's another thing. Snow level is another issue that we'll have to look at. And you can see in my picture here, this will be a little bit of a problem. So in my first house, I had some water lines that actually froze up, and the contractor who had installed the house, or installed the furnace in the house before I had purchased it, they had probably at best 6 inches above the grass, and that was all it took was the wrong winds, and things will happen. So snow intake level is a big one. Now we're in a northern climate. The bare bones minimum is that we get it at least 12 inches above expected snow level. Now that pretty much is a minimum requirement for most everywhere, but there's places that you might have 3 feet of snow. You better be very careful not to make sure, you better be really careful to make sure you have a sufficient amount of height for that combustion air so that it does not get clogged. Usually the exhaust pipe is not the one that's going to create the problem. It's more the intake pipe that'll either get full of snow or it'll plug up and it'll stop the unit from operating. So be careful with that. Let's talk about some of the issues related to venting a Category 4 furnace. So, all right, so I'm in a northern climate. We're in a northern climate. So if let's say that you go to an application and you have a water heater and maybe a Category 1 furnace or something like that are vented, and you're going to pull that furnace out. One of the things you're going to have to be very careful with is you're going to make sure you need to verify those chimney sizes are they appropriate for that existing appliance, such as that water heater. So if they're too big, you're going to just wreck that chimney and it's not going to work right. A lot of the codes, certainly in the city of Green Bay, and there's even more other areas as well, they will require you to use an approved chimney liner when you're removing an appliance and you're leaving a common vented water heater or some other appliance that all of a sudden this existing vent system, this B-vent system, might be even too big for that application. So, and certainly a chimney. But a chimney liner is very appropriate in there as a repair. All right, another thing to take a look at. What are some other things that we should consider? Well, certainly to never run a PVC pipe into a chimney that has other appliances venting in it. So first thing is that would put you with probably a Category 4 appliance being vented with appliances that are likely a Category 1 appliance, completely against any type of code issues. In this image on the left side, you can clearly see that there are some issues here with this appliance being vented in with PVC pipe going into this vent. This one as well. I don't know what they were thinking when they did that, but that is a real challenge on there. So it's just something you do. You can certainly use the chase if it's a chimney. So for example, like in the image that I have on the far right here, that particular image is showing PVC vent pipes going into a chimney, and as long as the other vent system isn't, if there's, let's say, a multi-flue chimney, that would be the only reason why I could see that maybe creating a problem for you. And the other thing that I would also be a little bit alarmed by what's shown here is the separation between the intake and exhaust is really not appropriate. I'm not saying that's a good application, but that's one that you'd have to be careful with. So what about some clearances? Let's look at some other things. So there's a whole list of items that are in here that I wanted to point out to you, and one of them is check your clearances for any of these installations. And this has to come from the install manual. The code book might have some guidance, but the install manual is going to have preferential treatment over the code book as far as the sizing and those types of applications. You'd have to plan on most manufacturers going back and looking at the codes to make sure that they're making their manual appropriate. So you have to look at both of them. And so some of the things that I wrote in here a little bit is, look at inside corners. What you don't want to have is you don't want to have it where those gases just can't get away and they're sitting in this corner and it just doesn't allow you to vent properly. Another one that you want to look at a little bit, it would be things like your dryer vents. So you could have a customer that's venting gases, venting lint and everything out of those dryer vents, and if your intake is too close, that creates a problem. Keep it. The rule usually is about 3 feet away from a dryer vent. You need to be at a minimum. Usually it's around a minimum of 12 inches away from an operable window. Now, windows that do not open would be exempt from that, but windows that are operable, you need to keep them at least a foot away from those for the exhaust gases, because you don't want to have it where a customer could open up a window, not that they would do it in the winter, but if they had the ability to open up a window, it could even be a slider, and all of a sudden the right winds and you're blowing gases into the building. Item number 4 talks about gas meters and regulators. So the rule usually is about 3 feet away. You need to stay away from the exhaust, and intake need to be kept at least 3 feet away from those regulators and meters. Plumbing vents as well. And I talked about that earlier about the predicted snow levels being 12 inches above. You need to keep those intakes at least 12 inches higher than the expected snow level. Be very careful also with chemicals in the air. So pools have chlorine, a lot of chlorine content, or they potentially could have that if they're using a chlorine-based chemical for sanitizing the pool. So be careful with that. Again, those are some of the rules. Be sure you check, install manuals. I can't underemphasize that enough. And of course, if the condensing furnace is going to be installed in an unconditioned space, what do you have to do? And there are times where you may have to do that. The first thing I would do is I would say absolutely verify that furnace is going to drain properly. Make sure that it's either level or has a slight pitch to the front or to where it's draining condensate. The second thing is you probably are going to need to use some heat tape around the condensate trap, which is shown here over on this side. And then you also would have to look at the drain lines. So whatever the drain lines are, if they freeze up, that appliance is going to stop. It's not going to work. So that's generally what you'd have to do on those. And of course, when you think about, what's the number one rule you need to think about when you're trying to figure out any venting issues, just, make sure that you've got sufficient, combustion air. Make sure that you can vent the products out safely, that doesn't create a problem, damage the property, anything like that. Those are typical what we have to do. And of course, if you are doing the questions and have done them already, you should be able to complete those and submit those as one of your assignments.